Hi class, for this module we want to talk about log functions and exponential function. These two functions are the inverses of each other. So before we begin, I just want to remind you that for this particular modules, you need to know the definition of log and exponential really well. So in a way, you need to know how to go back and forth between log and exponential. One more thing, you need to know the properties of log really well as well. So let's begin. Example 1, as I mentioned earlier, we need to know how to rewrite. So you see right here, what I have is in log form. So we want to rewrite as an exponential function. I have the definition right there for you. So you see right here, 7 is the base. So I'm going to write the base first. And then the exponent is 1 equals to 7. That's the argument. Okay. For b, it's the opposite. So I'm going to go ahead and put log. The base is going to be 2. I always write the exponents first. So I'm going to put negative 5 right there. And then 1 over 32. That's the argument. All right. Number 2. You see for number 2, we have ln. ln is when you have the base is e. So what we have right here, the base is e. So I'm going to have e, and then the exponent is 5 equals to x. Okay? So once again, e to the y, we have ln. So it's going to be ln of 2 equals y. That's the exponent. Okay, moving on, we want to evaluate. So before I evaluate, I always put a variable there. So I'm going to put, you can put x or you can put y. It really doesn't matter. So I'm going to put x here. So I'm going to have to rewrite 5 to the x power equals to 5. So you see that we have the same base. So the exponent has to be the same. So x equals 1. Okay. Same thing over here. I'm going to start with the base. I'm going to put x here. So to the x power equals to 1 over 32. I'm going to try to get to the base of 2. So 1 over 32, you can see that it's going to be 1 over 2 to the 5th power. If I want to move it to the top, it's become negative, right? So x is going to be negative 5. Okay. So you see right here, unlike evaluation, they ask you to solve for x. It's going to be the same idea. So I have 49 as a base to the 1/2, which is the exponents equals to x. So what you have right here is just pretty much taking the square root, right, of 49, which is 7. So that's going to be your answer. All right, graphing. Now, when it's come to graphing, you should definitely make table. I'm gonna go ahead and do the basic graph first. So I'm gonna check. I'm gonna take care of log base 2 of x equals to y. You want to rewrite into the exponential function so we can have the table. Now notice that I have y for the exponents, so that's why I make I pick y's and I solve for x. So you see right here what I have is negative 2, negative 1, 0, 1, and 2. So what I have, I take negative 2, I plug it in here. Okay, so it's going to be 2 to the negative 2, which is 1 over 2 squared, which is 1/4. Same thing over here. We have 1/2. 2 to the 0 power is going to be 1. 2 to the first power is going to be 2. 2 squared is going to be 4. Okay, so you can see that we have 1/4, negative 2, 1/2, negative 1, 1, 0, 2, 1, 4, 2. Now notice that the graph is going to move up 1. Okay, so shift up 1. So you plot the points and you go up 1. So what I have right here for the first point is going to be 1/4. negative 2. So 1/4 negative 2 is like right here. Oh, sorry. Let me just go back. So 1/4 negative 2 is going to be right here. And I'm going to go up 1. So it's going to be right here. And then we have 1/2 negative 1. So 1/2 is right here. Negative 1 is right here. So 1/2 is right. 1/2 is right here, right? Negative 1 right here, and then you go up 1. So you're going to get that point right there. Okay, 1 0. So 1 0. So it's right here, and you go up 1. So it's this point. Okay, and then I have 2 1. So 2 1 is right here, and you go up 1. So it's 2 2. 4 2. So 4 2 is right here. You go up 1, so it's 4 3. Now I'm ready. Okay, so that's how we graph a log function. All right, so same thing over here, but notice that we have x plus 1. So that means your graph is going to shift to the, your graph is going to shift to the left 1 unit. So same idea. First, we plot the points. You see right here, we have 3 to the y power equals to x. Okay, so I'm going to plot the point. 3 to the negative 1/2, that's 1 over 9. 3 to the negative first power, that's 1/3. If I plug in 0, I'm going to get 1. I plug in 1, I'm going to get 3. I plug in 2, I'm going to get 9. Okay, so let's do this. So same idea, okay? 1/9 to 1/9 negative 2 here. Okay, and don't forget you're gonna shift over 1. So we have right here. Okay, negative 1. Oh, I'm sorry, 1/3 negative 1. And you shift 1 over. And I have 1 0. So 1 0, and then you shift 1 over. So it's going to be right here. Okay, 3 1. So we have 3 3 1, and then I shift 1 over. So it's going to be 2 1. Okay, 9 2. So 9 2, and shift 1 over. So it's going to be 8 2. And I'm ready. Okay, so that's how we take care of the graph. Now, for the next problems, you see that we have to use the properties, and I have the properties right there for you. So make sure you memorize it. You have it memorized. So the first one is addition. Therefore, what we have is going to be multiplication here. So we simply take 5 times 8, which is 40. So your answer is going to be 40 here. Okay. So you see right here we have subtraction, and then they have the result here is 11 over 4. So it's going to be 11 minus 4. So that's what I have. And now this one right here, we have the exponents. Okay, so you see the exponents, they carry right here, so it's 2. So you need to figure out the exponents of this one. So we want to rewrite, it's going to be 2 squared. So you bring 2 to the front, so the answer is going to be 2 right there. Okay, now using the properties to expand it, so what we want is we want to use the 3 properties. So what I have is going to be log of x, and because this is multiplication, so we have log of x plus log of y. However, don't forget that for z, it's not x, so it's z here. Now, don't forget that for z, we have the 7 for the exponent, so you're going to put the 7 to the front. All right, so number 9, you see we have the cube root, so I would first rewrite as the exponent. So I can do this. C over y squared to the 1/3. Then I can definitely rewrite. So I have, I can rewrite the expression one more time and multiply the power. So for x, I'm going to have 7/3. For z, I'm going to have 1/3. And for y, I'm going to have 2/3. Now, when we expand it, it's going to be so much easier because we have 7/3 for x plus 1/3 for z, and then minus 2/3 for y. Okay, so if it's on the bottom, you subtract. If it's on top, you add. Now, for number 10, we want to write as a single log. This one is very important. So you need to rewrite. So somehow we have only one log and the base is a. So you see right here, we have the power for the z is going to be 1/3. Because we have addition, so it's going to be multiplication here. And then for y, it's going to be on the bottom. Okay. Now for number 11, okay, notice that if I have log base 4 of 3 and I want to find the exponents, we want to rewrite, right? So 4 to the x power equals 3. There's no way I can find that exponents by hands. So that's why we're gonna have to use a calculator, and we're gonna change the base first. So you see right here, I have a, b, and then we have a, b here. So c here, that's when you use your calculator, and in your calculator you're gonna have base 10 or base e. Okay, so we want to rewrite. So technically I can just put log over log, and the base, which is 4, is going to be on the bottom, and the argument is going to be on top. So then you can use your calculator for it. Log 3 divided by log 4. Okay. All right, solving. For solving log function, you just have to rewrite. Okay, first we have to isolate log. You see right there, log is isolated. So I have to use the definition, which is base raised to the power equals to the argument. So I have 3q equals 4x minus 1. And from here, you can just simply solve it. So I have 27 equals 4x minus 1. Add 1 over, I'm going to get 28 over 4x. So x is going to be 28 divided by 4, which is 7. Make sure you check your solution. You're going to have to plug it in here. Okay, see if you get the right answer. Okay, now for number 13. Number 13, you see that log is not isolated. So I have that 1 right here. So the first thing you want to do is you want to get rid of that 1. So first, I'm going to subtract 1. So now I have log base 2 of negative 5x equals to 3. Now we are ready to rewrite. So I have 2 cubed equals negative 5x. 2 cubed is 8, negative 5x. So x is going to be negative 8 over 5. Very important. Make sure when you check for your solution, make sure the argument cannot be negative here. Okay, so argument cannot be negative. Okay, so you see right here, I have a negative. I plugged in for a negative. It's going to be a positive. All right, number 14. Okay, so for number 14, you see that we have log here, and then we have a number. Okay, so the first thing you need to do is you need to isolate log, right? But we have two logs. So first we have to move them together. So the first thing I need to do is I need to take log and add. So I have log to one side. Okay, now I cannot rewrite into the exponential function right away because I have two logs, so we can combine it into one single log. So how do I combine it? I'm using the property, which is multiplication. Now I'm ready. So I have 2 cubed equals x plus 4, x plus 6. Now you can see that we can just proceed. You have parentheses, so the first thing you want to do is you want to FOIL. Now you can see that we have a quadratic, right? So we can definitely use, we can definitely factor, we can use quadratic formula. I suggest that you try to factor first, okay? So what I have is gonna be, first we have to make it into standard forms. I have to minus 8. So 24 minus 8, I get 16. Okay, I'm going to pick two numbers. When you multiply, you get 16. When you add, you get 10. So x plus 2, x plus 8 equals 0. So when I solve it, I have negative 2 and I have negative 8. Now this is important, right? We're going to have to go back and plug negative 8 in the original, plug negative 2 in the original. When you plug negative 8 in the original, you're going to end up with a negative 4 in here, a negative 2 in here. That's bad. So we have to cross it out. So your only solution is negative 2 because you plug it in, you get a positive number. That's very important. So for log, make sure you check your solution. Okay, moving on to number 15. So for number 15, you see that we don't have the same base. So recall, if you have the same base, b of x equals b of y, then the exponent have to be the same. So if you can rewrite and you can make them into the same base, we are good. So we have 2, so the fifth power, x plus 5. Make sure you put the parenthesis there. Now I have 2 to the 6th power. So it's important that you recognize that they share the same base, 2 and 2. Once you have the same base, you can just drop the base and then just solve the exponents. So I have a linear function. Okay, so you just proceed as usual, as the just pretty much linear function. And sometimes you're gonna run into quadratic. It's still okay because when it's come to quadratic, you can use quadratic formula or factoring. So what I have is negative 19 over 5. Okay, we have no problems with negative for exponents. Now, number 16. The problems with number 16 is there's no way I can rewrite 11 to get the same base as 3. So what can we do? We're going to apply the log function. So I'm going to apply log and log or ln so we can use the properties to rewrite. So how do I do it? I'm going to apply, like I said, I'm going to apply log 3 to the 3y and log 11. By the way, you can use ln if you want. Now, because I apply log, I can use the property. So I'm going to move the 3y to the front. And now I just solved for y. So y is going to be log 11, and I divide by 3 log 3. And then from here, you can use your calculator for it. Okay. All right. For number 17, same thing. But this time, I suggest that you use ln because we have e. So if you use ln, okay, you cancel out the e. So we have x plus 8 equals ln 8. And then you can just have ln 8 minus 8. Okay, simple. So once again, you use your calculator for it. All right, so you see number 18. I'm going to use, you see right here, you use either base 10 or base e. I'm going to use log, okay? So first I apply log. And then I move the exponent to the front. I'm going to put parentheses right there because we have two terms. Now you see that we have x on both sides. When you see parentheses, we want to get rid of it, right? So I'm going to have 9x log 14 negative x log 11 plus 2 log 11. Now what I have is x on both sides, so we have to move over. So I'm going to add 9x log 14 plus x log 11 equals 2 log 11. So how do I isolate x? I then gonna factor out the x. So I have 9 log 14 plus log 11 equals 2 log 11. Now you can simply divide, right? So I have x equals 2 log 11 over 9 log 14 plus log 11. So that's the exact solution. If they ask you for the numbers, then you use, once again, you use the calculator.